Hello and welcome to SudoKanard. We're here to solve this puzzle, which is called Expression X-Sum Sudoku. It was created by Chen for Sudoku Grand Prix. It was worth 97 points, which is a lot. And if you ask me, this puzzle was the hardest in a round. It was harder than the puzzles that were 124 points worth. It was very difficult. I did not attempt it during the contest, and I'm glad I didn't, because when I solved it afterwards, it took me quite some time. But that being said, it's an absolute banger. It's a fantastic puzzle, and I'm really enjoying the fact that I can display it on this video. I just hope I will find the logic. So this is X-sum Sudoku, which means that when there is a number here, then this number is the sum of the first few digits. How many digits are taken into account in the sum is given by the digit that is just here. So m, which has to be determined, and I will place the value here, is the number of digits. I need to add something. Yes, that's it. No, sorry about that. Yes. All right. So those letters represent numbers which are to be determined, and such a number is the sum of the first few digits, as I was just saying, and sometimes the number is the result of some operation, so subtraction or an addition. And this is all we have to work with Sudoku here, with max sums and sum, OK, US, and U plus D, which has no meaning, I'm afraid. Neither do those have meanings, but we have USA here for some obvious reason. And that is the first clue, that those numbers, US and A, are single-digit numbers. So that's the first thing. Oh, and the rules mention the fact that some of those letters may represent the same numbers. And I think this is not the case in the end, but this is not something, we don't have the information that all letters represent different numbers. Except that here, U minus S is the sum of the first few digits, so this is a positive number in a straight sense. This is at least 1, so that U is bigger than S, so U and S are not the same digit. And that's interesting, because now this digit here tells us how many digits will be taken into account for the sum, and the sum is a single-digit number. So this can't be more than 3. But 1 doesn't work, because 1 would say we sum only one number, and S and U would both be equal to 1, and this would be equal to 0, which doesn't work. So that's not 1. This is either 2 or 3. But we will see that 3 doesn't work either. Because if we try 3 here, then those must be the sum of all 3 digits here. And let's see what the minimum value here. The minimum value would be with 1, 2, 4, and 5 in there, which means that S plus U would be this plus that, which would make 18. So the minimum value would be 18, which means that the minimum value for S and U would be 9 for both letters, and the difference here would be 0 again. And the maximum value would be 9 also. So that doesn't work. So that this is actually a 2. And here we have the same argument. So that digit here is a 2. So that's the first thing. And U and S must be those sums. And something interesting here is that S now and U. So U, so S is at least 3, so this is never a 1. Oh, and I didn't mention it, but 4 and higher digits are impossible because the sum of 4 digits is at least 10. So this can't be 4 or higher, and it can't be 1 because S is more than 1. So that has to be a 3. And the same works here for U. No, not U, but letter U. What is the minimum value for S? Well, the minimum value would be achieved with 1 and 4 here, and it would be 8. And knowing that U is bigger than S, 8 is the only option. So we know that S is an 8, and U is bigger than S, so U is 9. And I will write the totals here. So this is 8, here this is 9, here this is 9, and here this is 8. And it gives us a few numbers, a few digits. That's a 6, that here is a 6, that is a 7. And S minus U is 1, so that here, that is 1, which means that we only sum one digit and that this digit is 1. So that's a spectacular start already. We need 5, 8, and 9 here. And we know that U is 9, that S is 8. We don't know the value of A yet. We don't know the value of U plus D. We don't know the value of X, but it's a great number. It's a very high number. The value of M, we don't know M, but it's a rather high number. And perhaps we can have a lower bound for M. A lower bound. Oh, by the way, this is a 7 to achieve this 9 sum. So a lower bound I was mentioning. So a lower bound would be achieved with 1, 2, 3 here. And in this case, so that would make 6, 12. And let's say we get 8 and 5, that's 25. So M is at least 25, which means that here, a lower bound for S plus U plus M is 25 plus 9 plus 8, which is 42. So here the sum is at least 42. And what we need to understand here is that 42 needs at least 8 digits. No, actually, oh, I said 42, but I was wrong. 42. So I say 25 for M, assuming 5 and 8 here, but this 9 is not here, so 9 on this row must be there. So there's a 9 here. So the minimum value here will be with 5, 9, and 6, which is 20. So that the minimum value for M is 26. So let's say 26, but this is not correct. So that's not a, or it could be, but we don't know at this point. So this is at least 26. And this is at least 43. And that's the point. 43 needs at least 8 digits, because only 2 would be left out, and we can see that 2 can't be left out actually. So we need at least 8 digits, and because S is equal to 8, this can't be 8, this has to be 9. And now this total, that's a very well-known secret in Sudoku, the total of all 9 digits is 45, which means that this is not 26 after all, this is 28. M is equal to 28. And because this is 28, we can see that 8 and 9 here would not work. If I try 8 and 9 here, that's 23, and that's a minimum of 29. That doesn't work. So 9 is here, but it's not 9, 8. So it's 9 and 5. That's 8. So we have 20 here. We need another 8 there without using the 5. Those must be 1, 2, and 4. 1, 3, and 4 to achieve this 28 clear. Here we're left with 2, 8, and 7. And guess what? There's a 2 and a 7 here. So this is 8 with 2 and 7 there. So this is the sum of all 8 digits, which is 45 minus 6. That's 39. U plus D is 39. U is 9. So D is 30. So D is 30 here, which means that the sum of all 3 digits here has to be 15. Oh, by the way, there is some roping here, so those are 1, 3, 4. Those are 5 and 6 in this order. Those are 2, 7, and 8. Those are 5, 6, and 9. That's not 8, that's not 3. So those 6 digits sum to 30, so those 3 digits must sum to 50. So those 2 must sum to 10, and the only possibility is with 3 and 7, and that's a 2, and there's no 3 in here. Which means that the sum here is 15. Oops, what am I doing? 15, I say. So K minus A is 15. We don't know the value of K, we don't know the value of A. We just know that A is between 2 and 9, so that K is between 17 and 24. 17 and 24, so this will be a 4 or a 5. (17 and 24). 7 is the sum of 7 digits. The minimum is 28. Minimum 28. K is at most 24. So this can't be 1. That's a 4. That's the 1. X minus K. This is from 1, 3, 5, and 9. X minus K, well, there's something between 19 and 27. This is not saying much at this point. So where is the next place to look? M plus A. M is 28. A is between 2 and 9. So M plus A is in the range from 30 to 37. So that is not 9. And an interesting point is that here we have a total of 9. So if this were a 6, knowing that those 3 digits sum to 9, those would sum to 36. But if that is absolutely incredible, I mean, if this were 36, because m is 28, a would be 8, and a is not 8. So this is devilish. So this can't be a 6 for this sole reason that if this were a 6, those would sum to 36 and a would be 8, which is not the case. So this has to be a 5. That's a really, really an incredible moment in the soul. And now this 9, those two digits must sum to 6 without using the 5. So there must be 2 and 4, which means that this here is a 5, this here is a 1. This here is a 7. And we're left with a 6 and a 9 here. So we know that m plus a now has only 2 values. Those digits sum to 21. Oh, and the sum must be at least 30. So the only option is with a 9 here and a 6 there. The sum is actually 30. Yes, I've already solved the puzzle, but I'm finding the logic all over again. And it means that a is a 2. Which resolves this, by the way. Wow. I'm still amazed at the logic behind all of this. And now that a is 2, we know that k is 17. And k is the sum of all 5 digits here. So those 4 digits must sum to 12 without using the 5. So there must be 1, 2, 3, and 6. 2 and 3 are not available here. 1 and 6 are not available here. And it disambiguates all of that. This here is a 7. This here is not a 9. Here we need 1, 4, 5. Here we need 7, 8, 9. And that's not a 7. And this is either 4 or 8. This is from 4, 7, 9. This is from 4, 8, 9. Now, where do we look next? Is it O? O minus K. Here we need 4, 5, 7, 8. That's not 7. That's not 7. 8 here. Actually, I know that K is 17. So the maximum value here. Yes, that's interesting. The maximum value for O would be with an 8 here. Removing the 1, it would be 44. So the maximum value here would be 27. So this is never an 8. 4 and 5 would both work, I think. And now what is the minimum value for this? The minimum value would be with, let's say, 4, 3, 5, and 8, and that would be 20. That's correct, I think. The minimum value here would be 20, something like this, so that the minimum value for O would be 37, which will never work with a 4. So that is an 8. And the value of O is 44. And the value for O minus K is 27. So how do we achieve 47? And is it a good question? I think it is. 4 would work with 6, 8, 9. Except that this wouldn't work. Let me just explain why this wouldn't work. I'm not sure if this is part of the intended logic. If I'm doing this, then this is 1, and I need 3 and 5 here, and this is where it breaks. I'm not sure this is part of the intended solution, but I'm seeing this, so I'm doing it. So 4 here doesn't work for this 27. This has to be a 5. So here we have 7. Those 3 digits must sum to 20. It could be 3, 8, 9. What are the options for 20 in 3 digits? One of them is 389, one of them is 479, but 479 doesn't work here. 569 doesn't work, 578 doesn't work. So this is really 389, and that's not 8. And 6 in this box can only be here. So that's 1, that's 6. Here we're left with 1 and 4, so this is 1, this is 4. By the way, this 4 is not here. Yes, this holds 7, 8. There's a 9 in here, so that's not a 9. Here we're left with 3, 5, and 9. So 9 is here, surrounded by 3 and 5. Here we need 2, 4, 8. That's not 8. And we need a 9. It can only be here. This is from 1, 3, and 5. So at this point, we need to address x and x minus k. So the possible values at this point for x minus k are 18 plus that, so the possible values are 19, 21, 23. And the possible values for x are this number plus 17, so at least 36, so 36, 38, and 40. 40, I'll say. Which means that the sum of those 2 digits here must be 45 minus this, so it must be 5, 7, or 9. 5, 7, or 9, so obviously this has to be a 4, and this has to be a 3. That's the only possibility. Which places the 9 there, the 7, the 9, 8, the 7, the 8, the 4, the 7. Yes, that works. And now this is 4, this is 1, this is 5, this is 9. And we know now that the correct value for x is 38. And x minus k is 21. So now all the clues have been found, and 21 means that this here is a 3. And the rest is Sudoku. And I hope it solves well. Here I need 6, 7, and 5, so that's a 5. That's a 6, that's a 7. Here we need 1, 3, and 6, so that's 1, that's 6, that's 3, so that's 2, that's 3. 5, 4, 1, 2, 8, 4. That must be a 2, that must be a 5, that must be 8. No fireworks. Oh, no fireworks. So there is. Where's the paper? Oh, okay. So you the paper. I solved it on paper. So, is there anything wrong? Well, I'm just reading the digits. Now. So all digits on the Sudoku part are correct. Perhaps when I created the pen pal interface, perhaps I made some mistakes in some of the other numbers. Well, anyway, you can see that even after solving this puzzle multiple times, it took me quite some time to solve it on video again. So I will say it again. I think 97 points was largely undervalued for this puzzle, but then the testers were faster than I was in solving this puzzle, so good for them. And I must congratulate again the people who managed to solve it during the contest. That's an amazing feat. And I must congratulate Chen for creating such an incredible puzzle, because this is really, really remarkable. I would moderate my enthusiasm by saying that I'm not convinced that this kind of puzzle is really a good idea for Grand Prix. Of course, there's a margin for originality, for innovation. But I think that this round had a lot of innovation. And innovation is good, but this amount of innovation in Sudoku Grand Prix, I think, is not quite in the spirit of what we're accustomed to. And perhaps this is something that should have to change. This is open for debate. Well, I'm not convinced that this amount of innovation is really good for this contest, but this is my opinion. You are free to disagree. Anyway, thanks for watching this video. See you soon on SudoKanard.